Hello viewers, in today's class we are going to discuss one important and conceptual problem from integrals involving modulus function, right? So in our previous video we have discussed the integral that is 0 to pi by 4 mod of sine x minus cos x, right? So we have seen in detail how to find the value of this definite integral using this graph, right? So we are now continuing that series, and in this lecture we are going to discuss this integral that is from pi by 4 to pi by 2, right? And here again we'll utilize this graph, right? So which was used for finding out the value of this integral. So now see here this blue curve, it shows the graph of cosine x, right? So this represent cos x, and here we have drawn only the upper part of sine x, right? So this red curve shows sine x and the blue curve shows cosine x, right? And it is quite evident from these two graphs or these two curves that sine x and cos x, they intersect at this point, that is pi by 4, right? Now because if we take the quantity which is inside the mod function symbol equal to 0, right? So if we take sine x minus cos x is equal to 0, then we have sine x is equal to cos x, right? And for x is equal to pi by 4, sine x is equal to cos x, right? So here we have this point pi by 4. Now let us see the limits, right? So here we have to integrate from pi by 4 to pi by 2, right? So here we have the point pi by 4 and here we have the point pi by 2. So let us consider the interval that is from pi by 4 to pi by 2, right? So when x lies between pi by 4 and pi by 2, then from the graph we can see that the value of sine x is always greater than cosine x, right? Because see, the red curve is sine x, the blue curve is cosine x, and when we go from pi by 4 to pi by 2, then this blue curve, it lies below the red curve, right? And this blue curve shows cosine x and the red curve shows sine x. So cosine x is always less than sine x when we consider this interval pi by 4 to pi by 2, right? Now if we take cosine x to this side, we get sine x minus cos x is greater than 0, right? Now let us consider the definition of mod function. So mod of p is defined as positive p whenever p is greater than or equal to 0. This is negative p whenever p is less than 0, right? Now see, here we have mod of sine x minus cos x. Now if we take sine x minus cos x as p, then we have p greater than 0 in this interval, that is pi by 4 to pi by 2, which happens to be our lower limit and upper limit, right? So p is greater than 0, it implies sine x minus cosine x is greater than 0. So by definition of mod function, mod of p is equal to positive p when p is greater than 0, right? So mod of sine x minus cos x is equal to positive sine x minus cos x, right? So this integral I can be written as pi by 4 to pi by 2, and here we have positive sine x minus cos x, right? And here we have dx. So now the integral of sine x is minus cos x, and the integral of cosine x is sine x, right? And the limits are from pi by 4 to pi by 2, right? This is pi by 4, this is pi by 2. So now let us substitute the limits and we'll take the difference. But before substituting the limits, let us take this negative sign outside the expression. So we have cos x plus sine x, and here we have pi by 4 to pi by 2, right? So now we have, first we have pi by 2. So this is cos pi by 2 plus sine pi by 2, and then we have minus cos pi by 4 plus sine pi by 4, right? Okay, so now we have minus, and cos pi by 2 is 0, sine pi by 2 is 1. This is 1 over root 2, cos pi by 4, sine pi by 4 is 1 over root 2, and this is minus 1 minus 2 over root 2. So this is 2 over root 2 minus 1, right? And rationalizing it, we'll get root 2 minus 1, right? So the value of this integral is equal to square root of 2 minus 1, right?